In this lesson, we're going to derive the demand curve, that downward sloping line that shows you how in a market the quantity demanded declines as the price increases. This is actually the first in a series of lessons that enables us to think about how markets work, where there are sellers and buyers and there's an equilibrium. In the first part, we're going to actually, as I say, derive the demand curve, and to do that we're going to look at the behavior of consumers and the buyers in the market. And then after we do that, we're going to derive the supply curve, which will focus on firms rather than consumers, the producers in the market, which will be the sellers. And then finally, once we derive the demand curve and the supply curve, we're going to think about equilibrium and efficiency, where the buyers and sellers come together in the market, and we'll see why markets work well and when they don't. So remember, the demand curve, as I say, is this downward sloping line between the price and the quantity demanded. And it's something that's the basic part of the supply and demand model. But now we want to really look at the consumers that underlie that demand curve, the people that underlie the demand curve, and really see why the demand curve has the shape it has, why it's downward sloping, and when it tends to shift. Now to do this, we're going to follow the following approach. First, we want to, as I say, start with an individual consumer. You can imagine it might be you, it might be me, it could be anyone. And based on that individual's behavior, we're going to derive that person's demand curve. And then from the demand curve, we're going to consider many such consumers who are in the market, many such individuals in the market, and get the market demand curve. Again, by adding up demand curves for many such individuals, we'll get the market demand curve. But let's start with the individual. To get the individual's demand curve, we're going to apply that general economic principle that people make purposeful choices with limited resources. That's the mantra that we've emphasized as a general principle of economics. When it's applied to the demand curve, we want to think about consumers. So we want to apply this principle to the behavior of consumers. In this case, the people will be maximizing their utility, we'll call it, subject to a budget constraint. So purposeful choices becomes maximizing their utility, which we'll describe in a minute. And the limited resources is going to reflect the fact they have a budget constraint, which means they only have a certain amount that they can spend in a particular period. So let's go with this. Utility, for an economist, is simply a numerical indicator of people's preferences. When this numerical indicator is higher for a particular bundle of goods with a certain number of apples and grapes or pears and oranges, when it's higher, then that person prefers that bundle. If it's lower than the other one, they don't prefer that bundle. So basically, a higher level of utility compared to another bundle represents preference for that bundle. You like a certain number of items A more than a certain number of items B, then the utility of A is higher than the utility of B. That's the concept. Now to make this work, I want to use an example, and I want to imagine that you or someone else is a consumer deciding how many pounds of grapes to buy in the supermarket, or how many pounds of bananas to buy in the supermarket. And so on the horizontal axis of this box, I'm labeling first the pounds of bananas, 1, 2, 3, 4, 5, and on the vertical, we're labeling the pounds of grapes, 1, 2, 3, 4, 5. And then inside the box, inside this matrix, we're representing the utility that this consumer gets from these various bundles or combinations of bananas and grapes. So for example, if the consumer has 1 pound of bananas, 1 pound of bananas and 1 pound of grapes, that's a utility of 16 by our assumption. We made up these numbers to illustrate it. For 2 pounds of grapes and 1 pound of banana, the utility is 20. So obviously the consumer prefers 2 pounds of grapes to 1 pound of grapes. And as you go up the vertical line there, 16, 20, 23, 25, 26, you see that that's increasing. And that means that it's more utility with more pounds of grapes, and therefore the consumer prefers that. If you notice, as you go up this column, the increments get smaller. So from 16 to 20 is 4, from 20 to 23 is 3, from 23 to 25 is 2, from 25 to 26 is 1. Those increments, sometimes called marginal utility, decline the more grapes you have. So the marginal utility, we call it, the change in utility as you consume more grapes, declines as you consume more grapes. You can look at the utility of bananas just looking in the horizontal direction. So for example, let's look, assuming you're have 1 pound of grapes and you're considering different pounds of bananas. So you get 16 for 1 pound of banana, 24 for 2, up to 31 for 5 pounds of bananas, along with that 1 pound of grape over in the lower right-hand entry. And then if you go up any of the columns, it's increasing utility for pounds of grapes. And if you go to the right in any of the rows, that's increasing utility for bananas. So that's our example of utility. And we're going to use this to derive the demand curve for this consumer, any consumer that's considering decisions about grapes and bananas. Now we want to consider the constraint that the consumer faces, the limitations on the resources. So we'll start by assuming that the consumer has $8 to spend on grapes or bananas. And we'll also assume, to get started, that the price of grapes is $1 per pound and the price of bananas is $1 per pound. And now in the same kind of framework, we can describe how much it costs to buy various pounds of grapes and bananas. So for example, 1 pound of banana, 1 pound of grapes costs $2. That's in the lower right-hand column of the table. If you get 5 pounds of bananas and 5 pounds of grapes, that's in the upper right-hand part of the column. That would cost $10. That's in the upper right there of this box. And all the other points in between are simply the price of grapes times the number of pounds of grapes purchased, plus the price of bananas, times the number of pounds of bananas purchased, and that gives you the various entries in the table. Now, in addition, what this table shows is the things that you can't afford. With $8, you can't afford to get the numbers that are labeled in red. That's too high. $9 is greater than $8 is not possible. So you can't consume 5 pounds of grapes and 4 pounds of bananas. You certainly can't consume 5 pounds of grapes and 5 pounds of bananas. Those are off limits. They're outside the budget constraint. So now what we want to do is consider how the consumer decides how many pounds of grapes and bananas to buy at different prices for grapes or bananas. You can imagine having a higher price of grapes. So take this table now, assumes the price of grapes is $2 rather than $1 as in the previous table. The price of bananas is the same, exactly $1. Budget constraint is still $8. And now in this table, I've made the red items the things that the consumer can no longer buy. So for example, with the price of grapes of $2, you buy 4 pounds of grapes, that's $8 right there. A pound of banana would be another $1. That'd take you to $9 in the entry that's in red in that particular table. So in this particular case, if you can't get that number. That's the 4 from the 1. That's cost $9. You only have $8. You could get that if the price of grapes was only $1, but now it's $2. So it's off limits. Okay, so now what we want to do is examine what happens to the consumer's decision when the price of grapes goes from $1 to $2. So now let's take that utility measure we had, which this box shows, it's just a repeat of the box we looked at a few minutes. That gives you utility for different pounds of bananas and grapes. This is the utility box. And now with the price of grapes $1 a pound and $8 to spend, we cannot get to those levels that are now in red because they cost more than $8. Those are the $9 and $10 entries. So they're now off limits in terms of this consumer. They're outside the budget constraint. The black lines are inside the budget constraint. The consumer can afford those. And so now we have an answer to our problem. How many grapes, how many pounds of grapes, how many pounds of bananas will this consumer consume when the price of grapes is $1? And the answer is 4 pounds of grapes and 4 pounds of bananas, because if you look closely at the table, that's the highest level of utility, 39, this consumer can get with $8 when the price is $1 for a pound of grapes and bananas. Okay, so that's our first prediction. Now what we want to do is say, what if the price of grapes goes up? What's that going to do to the decision? We now have the budget constraint again, put it in play. I've now made the items red, which are no longer affordable for this consumer because now the price of grapes is $2, and so that $8 doesn't go as far as it did. There's more entries that are made in red because they're not affordable in this case. And now of the non-red entries, the non-red levels of utility, we see the highest is 34, and I've made that in blue so you can see it. So if you think about this, we have a prediction that when the price of grapes went from $1 to $2 per pound, the consumption of grapes went from 4 to 2. That is just the demand curve we've been looking for, derived now from this basic principle of maximizing utility subject to this budget constraint. And we can graph this using those same points in a picture. So that's what this does now. You take the price on the vertical axis and the quantity demanded on the horizontal axis. And the points we're plotting now are the ones that we just got from that maximization of utility problem. So again, to repeat, we found that when the price of grapes is $1, which is marked on the vertical axis as 1, the quantity demanded of grapes was 2 pounds, and that's shown in the horizontal axis, and that's that black dot. And then when we raise the price of grapes to $2, we've found that the quantity demand of the grapes goes down to 2. Those are the 2 black dots. I've connected them with a line to illustrate it's a downward sloping demand curve. We could think of other possibilities, but that's it. That's the demand curve for grapes. Now we also want to think about other aspects of this, and when you do that, it's very important to think about 2 things that happen when we raise the price of grapes in this example. One was called the income effect, and one was the substitution effect. Very important concept in economics. The income effect led to a reduction in the amount of grapes consumed because effectively the consumer had less real income to spend. With $2 grapes are more expensive, so you had less to spend, so that would tend to make you want to consume fewer grapes and fewer bananas. But in addition, there was a substitution effect because grapes were now relatively more expensive compared to bananas. Went from basically the same price, $1 for a pound of each, and now the price of grapes rose, so it's twice as much, $2 compared to a pound in the case of bananas. So the consumer substituted away from bananas and in this case decided that the higher price was going to be resulting in fewer grapes consumed. So substituted and basically got fewer grapes as a result. So that's the income and substitution effect. Now let's go back and finally see about shifts in the curve. That's the same budget constraint we started with, $1 for grapes, $1 for bananas, a total $8 to spend, and that's what's, the red lines are off limits, outside the budget constraint. Now if in fact, and this is a change, we now change it to suppose that it's only $5 is the budget constraint, so we change that 5 to 8. Prices are still the same, $1 for grapes, $1 for bananas. And now because there's less to spend, there's less available to spend, there's fewer possibilities. So now all the red things are higher than $5, not higher than $8, higher than $5. So those are going to be off limits, and we can't consume those. So now we want to say what's going to be the maximum level of utility achieved with this new budget constraint. And here's what it is. So I'm taking a utility table, and now I'm making red all the items that are not available in the sense there's outside the budget constraint. You can't get to those utility numbers. They require too much money. And of the remaining non-red items, I've made 32 be the highest possible utility level that's left over, higher than any other non-red items. And that suggests that 2 pounds of grapes and 3 pounds of bananas will be consumed as the consumer has less to spend, that it's moved from $8 to $5. And we can graph this as well and show you a shift in the demand curve. So what's happened here is we took the original demand curve, which represented a budget constraint with $8, that's the one over to the right, and when the budget constraint is now moved from $8 to $5, we've seen the number of grapes consumed, quantity demanded has gone from either from 2 to 4 at the bottom end there, or from 2 to 1 in the upper end. So from 4 to 2 or from 2 to 1, but they're both shifts in the demand curve, and that's occurred because of the change in the budget constraint, less money to spend, less income to spend, and therefore the demand curve has shifted. And so in summary, we have derived the demand curve. We've shown how higher prices reduce the quantity demanded based on utility maximization ideas, and we've also shown how the demand curve shifts when income changes based on the very sound principles of economics. And now we're going to consider in the next lesson yet another way to derive the demand curve, which has even greater applicability.